In this lesson, we will learn how to solve two-step linear equations. The directions are to solve, and solve means to find the solution set to an equation. Here are the steps that we follow in solving a linear equation. First, we simplify both expressions. Taking a look at each of the expressions, the left-hand expression is already simplified, there's nothing we can do to it, and the right-hand expression is also already simplified. Now we move on to step 2 in the steps in solving a linear equation, which is to get your variable to one expression. Our variable, g, is in the left-hand expression, but not in the right-hand expression, so it's already in one expression. The third step is to get your variable alone, and there are two sub-steps to that. First, we must move all terms without our variable in it to the other expression by adding the opposite. Looking at the expression with our variable in it, we find that there are two terms, 2g and 3. So we need to get rid of the term without our variable, that's 3, by adding the opposite. So we'll add negative 3 to both expressions, which will leave us with 2g equals 12. So we've performed step 3a, but our variable is still not alone, so we still have to continue. 3b, multiply both expressions by the reciprocal of the coefficient. Here the coefficient is 2, and you should always box your coefficient and then multiply by its reciprocal in both expressions. The reciprocal of 2 is 1/2, so we'll multiply by 1/2 in both expressions. In the left-hand expression, that'll leave us with just g, and in the right-hand expression, we're multiplying with fractions, so we should write everything as a fraction by putting it over 1. And now we can cancel. 2 goes into itself once, and into 12 6 times, which will leave us with 6 times 1 in the numerator, over 1 times 1 in the denominator, and we never need to write 1 in the denominator. So we find that g equals the set consisting of 6. Let's move on to another example. The directions are still to solve, and it's a linear equation, 2 minus 4g equals 19. In step 1, we simplify both expressions, and here we can change subtraction to addition by adding the opposite. Now both expressions are simplified. Next, we need to get our variable to one expression. Looking at this, we see that our variable is only in the left-hand expression and not in the right-hand expression. So step 2 is done. Step 3, get your variable alone by first moving all terms without your variable in it to the other expression by adding the opposite. Here, we have a 2 that doesn't have our variable in it. So we need to get rid of it, or rather move it to the other expression, by adding the opposite to both expressions. So we add negative 2 to both expressions. That'll leave us with, in the left-hand expression, negative 4g, and in the right-hand expression, 19 plus negative 2 is 17. So step 3a is finished. Now all we have is step 3b, which is to multiply both expressions by the reciprocal of the coefficient. Here the coefficient is negative 4. So we need to multiply by the reciprocal of negative 4, which is 1 over negative 4. And we do this on both expressions. In the left-hand expression, just like it should happen, our negative 4's cancel, leaving us with just g. In the right-hand expression, we're multiplying fractions, so we should write everything as a fraction by putting it over 1. Now, we multiply straight across, since there's nothing we can cancel. 17 times 1 is 17, and 1 times negative 4 is negative 4. We've got our variable alone, so this is our solution. So g equals the set consisting of negative 17/4.